Hi guys, this is our Unit 6 Vocabulary Data and Variation Data, the second section that you've got. This is from the OpenStax College Introductory Statistics and College of Coastal Georgia. Prepared these slides, so I want to make sure I've got that in. We are doing sampling and data, which is chapter 1 there. For us, this is module 6. By the end of the chapter, you should be able to recognize and differentiate between key terms and apply various types of sampling methods to data collection. All right, definitions. The science of statistics deals with the collection, analysis, interpretation, and presentation of data. So, you've got a bunch of different stuff involved in statistics. We will basically be doing collection, analysis, and interpretation, not so much presentation. Organizing and summarizing data is called descriptive statistics. Two ways to summarize are by graphing and using numbers, like what we've been doing before, your mean, median, and mode. After you have studied probability and probability distributions, that is in Module 7. It's all probability distributions. You will use formal methods for drawing conclusions from good data. The formal methods are called inferential statistics. And that is your Module 8. It's basically drawing conclusions, and you'll have a project. Statistical inference uses probability to determine how confident we can be that our conclusions are correct. Okay. Probability. You've studied probability before. It's a mathematical tool used to study randomness. It deals with the chance or the likelihood of an event occurring. It came up actually to study how you're going to win stuff in games of chance, poker, tossing a coin. Now we got the lottery. That's pretty much how probability even came about. People studying how likely is something to occur. In your study of statistics, you will use power of mathematics through probability calculations to analyze and interpret your data. Remember, the basic probability was what you want to happen versus what is possible to happen, what is possibly going to happen. All the possibilities. Okay? At the top is always just what you want. Okay? So if you're looking for the probability of tossing a coin, you get a head. There is one head, and that's what you want, but there are two sides. Okay? There's one head and two sides. All right. In statistics, we generally want to study a population. Now, the population are all the possibilities. That's everything. Population is a collection of persons, things, or objects under study. To study the population, you get a sample of it. The idea of sampling is to select a portion of the larger population and study that portion to gain information about the population. Okay, so you really have to make sure that your sample is representative of the population you want to study. Let's say that I wanted to, the whole population is the school. And my study, I wanted to find out how popular are hair bows. I'm not going to go get my sample from the football team. Most of them don't wear hair bows. Okay? You're going to want to go somewhere that is representative of the whole population. A random collection of people in the cafeteria. So, You want to make sure that it's representative of the population. All right. There you go. To gain information. Data, or data, either one you want to say, are the result of sampling from a population. This is the plural. That's why it's got R. If you're looking for a singular item, it would be datum or datum, either one. All right. So, if you're looking at overall grade point average at your school, you would take a sample of people, just general, to find what that overall grade population, what the grade average was in that sample, and then you could generalize it to your whole school. The opinion poll samples, I'm sure you saw all of those last November when they were doing the presidential election. They would take a sample of the population. It's impossible to actually poll 300 million people. So they would take a sample population to get a representation of what we could look at. Manufacturers take samples out of their products to see how reliable they are. Is this drink plus or minus the 16 ounces it's supposed to be? Is it within an acceptable scale? All right, from the sample data, we can calculate a statistic. A statistic is a number that represents a property of the sample. The statistic is an estimate of a population parameter. A parameter is a number that is a property of the population. The accuracy of this estimate depends on how well the sample represents the population. Just like I told you, you've got to make sure it's representative of the population. Okay, the accuracy depends on how well it matches. The sample must contain the characteristics of the population in order to be a representative sample. Okay. A variable notated by capital letters such as X and Y is a characteristic of interest for each person or thing in a population. Variables may be numerical or categorical. Numerical variables take on values with equal units such as weight in pounds and time in hours. Okay? So you've got actual values. Categorical variables place the person or thing into a category. Examples: political affiliation, eye color, gender, ethnicity. All right. Data are the actual values of the variable. They may be numbers or they may be words. Datum is a single value. Okay. Let's look at examples here. Maybe we can make sure you understand what the differences are with population, sample, parameter, statistic, variable, and data. Determine what the key terms refer to in the following study. We want to know the average, the mean amount of money first-year college students spend at ABC College on school supplies that do not include books. We randomly survey 100 first-year students at the college. 3 of those students spent $150, $200, and $225, respectively. Okay? So the population, that's everybody. So what you're looking at there is first-year college students at ABC College. That's your population. Okay, that's everybody that you're talking about. First-year college students at ABC College. Oops. There we go. Your sample, okay, could be all students. Your sample is those 100 students, but how you get them is your sample. It could be all students enrolled in one section of beginning statistics course at ABC, although it may not represent the entire population because not everybody is going to be taking statistics. Okay, a lot of majors require it, but a lot don't. Your sample is those 100 first-year students, but you got to find a first-year class. So we can put that down where you would come up with first year. Maybe you select 100 in an orientation during orientation week. You could find them there. Okay. Parameter. Parameter is the mean amount. That's what you're looking for. Mean amount of money spent, doesn't include books, by those students in the sample. They're still first year, by the way. Students in sample. First year or freshman students. Okay, your statistic. Oh, parameters in the population. I did tell you that. Okay. Parameter is everybody. Okay. Parameter, population. Okay. The same thing you've got right here. This mean amount of money. Let's see if I can get it to select here. The mean amount of money spent by students in the population. Can't. Okay. Parameter and population match. The mean amount of money spent by students. This matches too. Spent by students in the sample. The S's match here. So your parameter and statistic are about the same, but one's population and one is sample. Okay, your variable. The variable is the amount of money spent, okay, by one first-year student. So, let your variable x be the amount of money spent by one student, because that's what we got. 3 up here are 150, 200, and 225, and that is your data. Okay, that is the dollar amounts spent. Okay, that 150, 200, and 225 are examples. All right, that's 14 minutes. That's kind of long, but hope you stuck with it.